All right, one says to find the circumference of F. So you're working backwards because you have the arc length, right? 64 is the arc length. So you need the length, the formula is the length of the arc equals the measure of the arc over 360 times circumference or times 2 pi r. Because you're looking for circumference, you could literally leave it as the circumference and then just solve for it. So the length is 64. The measure of the arc is 210, and then it's over 360 times c.
2 pi r.
Right, so 2 pi r is circumference, and because you're looking for circumference, you could do 2 pi r, but then you got to work backwards again to get the circumference, so it's just a little bit of wasted time. So from here, I would literally cancel through the zeros, make them smaller numbers. And then because you have your calculator, I would just multiply by 36 and then divide by 21. So 64 times 36 divided by 21 is 109.7.
Why are we using 64?
Because 64, that's the length.
Wait a minute. Wouldn't the length be 210?
No, that's the measure. Remember, measures in degrees. Length is 64. I mean, length is in inches or centimeters, like a unit like that. Yep. So same thing. So you have, this time you have the radius. So you have the length. You don't have the measure of the arc. And I would do 2 pi r because you have the radius.
What do we put for the length?
The length is 35. The measure of the arc is what you don't know. Times 2 times pi times the radius, which is 27. And then you can do this in multiple parts. You could simplify the right and then move it. Like this is 54. So I could divide both sides by 54, and then I could divide by pi, or I could divide them together as long as I put them in parentheses. 35 divided by 54 times pi, again in parentheses. And I get measure of the arc over 360 equals 0.206. And then I'd multiply both sides by 360. So interesting that today it bothers him. 74.27 or 74.3.
Hardest going to get for the circle?
For the circles, yeah.
Yes. Okay. Oh, I had it right. She said didn't like. And are we gonna use soak? Are you gonna use soak and toe with the -1 just to find the reason?
No.
No.
Other questions on 11? So what I have you skipped 11, right? Yeah. Nick.
Why is it only Nick? Why?
Because he's raising his hand. I will do 3. Did you ask for 3? I will do 3 since we're up there. All right, it says area of the shaded sector. So I want the area of the blue. So this time the area is the measure of the arc over 360 times area, pi r squared.
So the only difference between not area and area is pi r squared.
Correct. The only difference is, yeah, because length is a portion of the length, which is a portion of the circumference. Area of the sector is a portion of the area of the circle, which is pi r squared. So this time the 105 is on this side, and I want the blue. So I have to do 360 minus the 105 to get that part of your measure of the arc. So that's 255, sorry, over 360 times pi. The radius is 8 squared. So 255 over 360 times pi times 64. And then you have your calculator, so let your calculator do all of it. Multiply straight across. 255 times pi times 64. Good morning. Thank you. And then divide that by 360. 142.4. I think, did it say what's around to? No, it'll tell you. Well, it's multiple choice, so you'll know.
Thank God. Wait, is every final multiple choice?
No.
Like we can't. Oh wait.
It's up to the department. Other questions from this page?
We're gonna have to do ones like 7, 8, and 9.
You're gonna have to, yeah, one is like that. You don't have, I mean, yeah, there's one question where you have to do your faces for a season.
Is there gonna be a question like you have to find the area of the circle and then subtract from the rectangle one?
Like the shaded region one,
Yeah.
it could happen in either probability or just area. Yeah. Nick.
Do you need to do number 5?
Oh, 4 you didn't need to do either. I didn't even catch that yesterday. Sorry. 5 and 6, yeah.
I got the answers. I just like don't know how to find the probability.
Okay, so if you want to find the probability, it's in the entire thing, you're going to find the area of the whole thing, and then you're going to take the probability, like the area of what you found. So you found the area of the red region?
I found the area of the red region and the blue region.
Okay, so then we got to divide it by the whole thing.
Okay.
So depending on how you do it, right, you could either do the square, probably the easiest is to do the area of the square, which is 10 times 10 or 100, plus the area of one circle because half is here and half is here. So if the diameter is 10, then the radius is 5, and the area of that circle would be 25 or pi r squared, so 25 pi. 25 pi. And you'd get 178.5. That's the area of the whole thing. So then you would put both of those areas over that 178.5.
All you have to do is just divide it.
Yep. So area of red was the circle, right, which is 25 pi over 178.5.
I don't remember doing probability with square.
We totally did area probability.
Yeah, we did area. It's
Did,
like, what's the area of the rectangle?
no, we did probability with area. And then the blue region, you'd have to do the square, which is the 100, minus the circle. And that's 21.46, and then divide that by the 178.5. 0.12. So area of what you want over area of the whole thing. That's how you find the probability of that. So Santi, we did that probability in chapter 11, not in chapter 12, if that's what you're confusing. Probability of with area? Yes. Okay, so that's like 11. 11 says you choose a tile at random. What's the probability you choose a number less than 10 or not? So when it's or, right, this is our addition, but with or, we have to check disjoint or overlapping. Overlapping means it can be both of the things. Disjoint means it can't. So when you're saying a number less than 10 and odd, is it possible for it to be both of those? So that's overlapping. So with overlapping, we do the probability of the first, which would be less than 10 in this case, plus the probability of the second, which is odd, minus the probability of the overlap. So the probability of less than 10 and odd. So if there's a bag containing 12 tiles, then how many of them are less than 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 out of 12. Odd, 1, 3, 5, 7, right? Half of them, 6 out of 12. And then less than 10 and also odd would be 9, 7, 5, 3, 1. So it's 5 out of them. So this is 15 minus 5 or 10 out of 12 or 5/6. You're welcome.
Was a disjoint or overlapping question?
Say that again.
Was a disjoint or overlapping?
What is a disjoint?
It was this
It,
one?
yes. If it says or, you have to figure out if it's disjoint or overlapping.
So was it disjoint or overlapping?
What?
Was it disjoint or overlapping?
This one is overlapping because a number can be less than 10 and also odd.
I didn't know if it's overlapping or disjoint.
If it could be both. So can it be less than 10 and odd? Yes, right? So that's overlapping. If it was less than 10, or if it was less than 5 and greater than 7, those can't be the same. So that would be disjoint. And that you would just do the probability of each and add them together. You're welcome. Other questions on, yep?
Is there a question that's like on here about probability of B if A happens?
So that would be an and with a replacement, or without a replacement. 12 is, good morning, Mr. Saxon. So that would be like something that would say, like you pulled something out and you kept it, right? So if it's dependent, that's what you're doing. If what you do the first time affects what you're doing the second time, then that would be dependent, and dependent means probability of the first times probability of the second, given that the first already happened. So I have a quiz. There's a couple questions on probability, and there's one like that. Yeah.
For like 13 through 18, you just have to like subtract like 1.
13 through 18. No, these are not, this isn't complement. This is, you got to figure out your and or, and this would be independent or dependent. So like 13, 14, 15. I mean, there's not going to be a whole lot of this. You just kind of have to understand what you're doing here. If it's or, right, then I'm going to add these two. If it was and, I'm going to multiply. 14, add for the or and multiply for the and then 15 is the one that's the complement, where you would do 1 minus x to get 2/5, or 1 minus 2/5 to get you x, because it's the same thing. That one's the complement. And then 16, 17, 18. So these are the ones kind of like what you're talking about, Zoe. Like if it's independent, then there is no, you just multiply them. This I would just multiply. But if it's dependent, you have to figure out what would happen. So you would multiply these. You're still multiplying. But B given A would be affected by what happens in A. So you have a box full of socks. Somebody pulls out a sock and keeps it, and then pulls out a second sock. Now that's dependent. And that one would be your P given B. I mean B given A.
So how do you solve
17, you're just going to divide because there's still multiplication.
So even though it gets affected, you just do.
It's just that this would be different. Like this one says B given A and this one just says B. It's still multiplication because they're still and statements, so it's still multiplication. So
all it is just multiply.
16, 17, and 18, yes, because they're all and statements.
Like 17 would be 60 times x equals 25. There's 60
Yes.
equals 25.
So you do 25.25 divided by 0.6. Yeah. But the wording on it is what's different. So like box, like drawer of socks.
Yeah.
Let's say there are 5 black socks, 4 white socks, 3 blue socks. Okay, so first scenario, you pick one, put it back. Second scenario, you pick one and you keep it. And then for both of these, we could say, what's the probability of getting 2 white socks? So is A independent or dependent? Independent, because you put it back. And for this one, we do probability of first times probability of second. So probability of getting the white times the probability of getting a white. There are 4 white socks out of a total of 12 socks. And then the second time, because it's independent and you start with the same set, it's still 4 out of 12. So 1/3 times 1/3, or 1/9. Whereas if you pick one out and you keep it, this is dependent. And so you do the probability of the first, or A, getting a White Sox, and then the second one, probability of getting a second White Sox, given you already took out and kept that first one.
So is it 4 times 0?
It's 4 to 12 times 3 over 11. So the number of White Sox change and the number of total Sox change. Well, this actually can get reduced. That's a 1 on the top. Other questions?